Hi there, welcome to another video. Today I'm going to focus on solving rational equations. Okay, so before we focused on simplifying rational expressions by factoring it, canceling what we see on both sides, maybe we're combining the two fractions together. We also looked at the idea of NPVs, what they are, why we have to kind of acknowledge them, how they look on graphs. So when we're solving rational equations, we're kind of putting that to use, right? So a rational equation, let me just write down an example here. So let's say it's something like x over, 2x minus 3. So that's something we're used to seeing. That's a rational expression. We're expressing something using a rational kind of this fraction with that variable in the bottom, right? And we're going to say that's equal to the other rational expression, 3x over x plus 11. Okay, so if the question is saying solve this equation, it's not saying simplify this equation, it's saying solve it. So when we're solving something, we're trying to isolate for a variable to figure out what it is. Okay, so we're trying to figure out, in this case, our variable is x. What value for x or values for x can we put in for x to make the left side equal to the right side? That's the main difference from equations and expressions, right? So an expression doesn't have a ton of meaning. It's not saying it's equal to anything else. Well, this is saying we have to figure out what x is to make it equal on both sides, okay? Because we don't know yet. So we might have to simplify, we might have to factor, and I'm going to teach you how we can kind of solve these equations. So how would we solve this one? So there's only one thing on each side, right? There's one expression on the left, one expression on the right. And in that case, whenever you see this happen, I would say the easiest thing to do is multiply. It's called cross multiplying. So we take the bottom left, right, the denominator of the left side, and we multiply it by the numerator of the right side. So we go down and up, right? We go across. That's why it's called cross multiplying. And we multiply these. So we say 3x times 2x minus 3. Okay, and then we're going to say that is equal to the other side, right? The top left times the bottom right. So x times x plus 11. All right. Now the next thing I'd probably say we should do is we should expand the 3x into the bracket here, and I would expand the x into this bracket over here. So 3x times 2x is going to give us 6x squared, right? And 3x times negative 3 is going to give us negative 9x. And we're going to say that's equal to this x times x, which is x squared, and then this x times the 11, so that's positive 11x. Now we're going to try and figure this thing out. So lots of times people would say, oh, well, every term has an x, so if we divide by x on both sides, then we can cancel a factor of, or we can cancel like this x here, and then we can lower this degree by 1 and cancel this x, blah, blah, blah. And that's not going to work because anytime we divide by x, we're ignoring a solution entirely. Okay, so anytime you can divide by x, that means the solution is going to be x equals 0. And you'll see why in a second. So if every term has an x, just for now, hold off. Don't divide by x because if we move everything to one side, let's subtract x squared and subtract 11x. Right, so we minus x squared minus 11x. We get 6x squared minus x squared. That's going to be 5x squared. We get negative 9x minus 11x. That's going to be minus 20x. That's going to be equal to 0. Okay, and then the next thing we do, we want one side equal to 0, right? Because we have a quadratic. Anytime we have a quadratic, we want one side equal to 0. So now we can factor this. We have to see what factors both of them have. So 5x squared and 20x both have 5x in them. We can divide it evenly. We can divide both numbers evenly by 5x. So take out 5x, we get x minus 4 on the inside, and that's going to equal 0. Okay, and we're saying that these two things multiplied together should equal 0, right? So that means either 5x equals 0, because if this is 0 and this is some number, 0 times some number is always 0, or that means x minus 4 is equal to 0. So if either of these brackets are 0 or both of them are 0, then the whole thing multiplied together will be 0. So just solving for x, we divide by 5, right? X equals 0 over 5, so x is 0. Add 4 on both sides, right? Isolating for that variable. X is going to be equal to 4. So these are our two solutions. And up here in this step, if we just divided by x, up here in this step right here, if we divided by x, our only solution that we would have found was that x equaled 4, but we would have totally missed this x equals 0 solution. So if you can divide by x, just keep everything there, move everything to one side, and then factor out that x like we did, right? Because then you'll find that your solution is x equals 0, and you'll get the right answer. Okay, so that's my first example. That's how you cross multiply with rational expressions. Now let's do an example where we're not going to be able to cross multiply as easy, and we can use another method. Okay, so let's say we had 2x over x minus 3. And let's say we had two rational expressions on the same side being added together. So it was the sum of two rational expressions that was equal to another rational expression, let's say x over x plus 3. So in this case, we're not going to be able to just like cross multiply right away because we can't like just do this and then do this, right? Multiply those two because we're left with this guy over here. So what we have to do is we have to kind of merge these fractions together, right? And if we want to merge those fractions, we're going to have to make a common denominator. Okay, so if this is x squared minus 9 on the bottom, let's just factor that actually. So that's a difference of squares. Instead of x squared minus 9, that's going to be x plus 3 times x minus 3. Right, so if we want to make this denominator the same as this denominator, we're going to have to multiply this side, right, by, we're going to have to multiply this whole thing, right, on the top and bottom by x plus 3. So this is by x plus 3. So x plus 3 times 2x, that's going to give us 2x squared plus 6x over our new denominator of x plus 3 times x minus 3, right? And then we have this 6 minus 2x. And this part, the numerator of this fraction, this rational expression, is staying the same because our denominator was already what we wanted it to be, x plus 3 times x minus 3. Okay. And what's that going to be equal to? Well, if we made the common denominator on the left side the same, right, that was our focus, why not do it to this side? So the only thing we have to do to this guy right here is multiply by x minus 3. Now this one's the same, and we can just distribute that x into there. So we get x squared minus 3x in the numerator, and we have our common denominator of x plus 3 times x minus 3. Okay, so now our denominators are all the same everywhere in this equation, right? So anytime you see that happen, that means that we can cancel them all out. Okay, so if we multiply both sides by x plus 3 times x minus 3, that means that we can cancel the bottoms out completely, and all we're left with is a super easy equation. So we have 2x squared plus 6x, right? There's no more, it's not a fraction anymore. It's not a rational expression because we canceled out the denominator. So we have plus 6 minus 2x. That's going to equal the numerator of our top here. The numerator of the right side, so x squared minus 3x. Okay, so now it's a little easier to work with. Let's just combine like terms. So 2x squared, it's the only x squared term on the left, so we'll leave that as 2x squared. We have 6x minus 2x, so that's going to be plus 4x, and 6 is our only constant on the left. So we'll leave that equals x squared minus 3x. Okay. Now what do? Well, we have a quadratic, right? Because we have that x squared term, those two x squared terms. So we always want one side equal to 0 when we're dealing with quadratics. So let's minus x squared and add 3x. That way, on the right side, those will cancel. We'll have 0. And what you do on the right, you have to do on the left, or vice versa, right? Because it's an equation. So 2x squared minus x squared, that's just 1x squared. 4x plus 3x, that's plus 7x. And then 6 is still the same because there are no like terms to go with that. Now the only thing left we got to do is factor it and ultimately solve the equation. So since we have a quadratic with a coefficient, that imaginary coefficient of 1 in front of the x squared, we're looking for two numbers that multiply to 6 and add to 7, right? We get our two brackets. Each bracket leads with x, plus, plus. Two numbers multiply to 6, add to 7, right? Well, the factors of 6 are going to be 2 and 3, and 6 and 1. Those are the positive factors, so 6 and 1 is going to be our answer, right? Because that adds to 7. So it's going to be x plus 6 times x plus 1. That equals 0. Okay, now that it's in factored form, right, this bracket is multiplying into this bracket. And if multiplied together, that equals 0, that means that either x plus 6 equals 0, right, or x plus 1 equals 0. So we can solve this equation for on the left side by subtracting 6 on each side, x equals negative 6. And we can subtract 1 on both sides from the right, right? So x equals negative 1, and these are our two answers. Okay, so that's how we can solve rational equations. And don't forget, whenever we're solving rational equations, we also have to state our NPVs. Okay, so in this first one, let's just quickly do that. I'm just going to erase some of the stuff here. Going to erase this line so we have some room to work with. Okay. So NPVs, always set the bottom equal to 0. So the bottom here is 2x minus 3. That cannot equal 0. So we're going to add 3 on both sides, treat it like an equal sign. 2x equals 3. Divide by 2, so those 2's cancel. X equals 3 halves, or 1.5. Okay, the other NPV we have is this guy over here, x plus 11. That can equal 0 as well. And we just subtract 11 on both sides to isolate for that x, so x can equal negative 11. Okay, so these are our NPVs. I forgot to put the can equal sign here. So x can equal 1.5 or negative 11. And if it did, then you would get your rational equation or your rational expression to be over 0, which is undefined. Okay, so our solution was 0 and 4, and let's just find our NPVs for this original equation here. Okay, so our common denominator was x plus 3 times x minus 3. So that means that x is not going to be able to equal plus or minus 3, because if it equaled either of those, then this would be 0, this would be 0, and this would be 0, which we don't want because the denominator can never be 0 or else the function's undefined. Okay, so that's how you solve rational equations. I hope this helped, and I'll see you soon.